Welcome to this talk. It's so good to see in-person conferences again. I can't tell you. I guess that everybody's feeling the same, but I just felt like I had to say that before we start. So we are going to talk about several new features of Java 17. Technically speaking, they are not necessarily exactly 17. Some of them have been released before, but because 17 is the LTS and the version that most of the projects are going to take to adopt, compared to 16 or 18, for instance, we are going to stick to 17 and 18 also a little. And I will tell you when I'm showing you something, if this is something that you can use in 17 or not. Right. And I would like to show you things from the perspective of really writing code. Okay? How can we leverage records? I guess that some of you at least have heard about what records are. How can you use records to improve the quality of your code, to make your code more readable and easier to understand? That's really my point of view, my perspective in this talk. And we'll be also talking about pattern matching, and I will show you several patterns to use pattern matching with the same perspective. How you can use pattern matching to write better code, better organized code, and this is what we are going to talk about in this talk. My name is José. You have my Twitter handle here. I work at Oracle in the Java Platform Group as a Java developer advocate. I've been recruited in this group just a year ago. And before that, I was working at a university in Paris. I've been doing that for 25 years. Here are a set of links that you can try with various content. There is also my Twitter account, my GitHub account on which you can find several elements. And I'm going to give you a specific link of a lab we did yesterday with the team on the exact same topic I'm going to talk to you just now. We are also publishing a bunch of content on the YouTube. You can follow the Java account, which is the official Java account on YouTube. I guess everybody knows YouTube, of course. I'm recording, hopefully, every month, unless I'm talking at conferences, a small series called the Jeb Cafe. And I'm also an author of a pro site, so here's the link to the courses I have there. And we just opened, with the release of Java 17, which was a little more than 6 months ago, a new website called dev.java. This is the URL of the website. The .java TLD is ownership of Oracle, so we were allowed to do that. And this is, I would say now, the official documentation of the Java platform. We updated a bunch of content that was already available for Java 8, and now it's up to date with Java 17 and hopefully Java 18 in the next few days or few weeks. There's also already a bunch of content on this website. There are about 1,000 pages if you print everything. Don't do that, please. This is the amount of content that you can find here. So please visit this website if you're looking for documentation. And the first thing I would like to talk to you about is records, precisely. We're going to start with that. Here is the link to the lab we did yesterday here at Devnexus. It's an 8-hour lab. The slides are going to be published on a separate URL, but you have the code here. So if you're interested in all this stuff, you can visit this code and work on the lab. And if you have any questions, you can ask them on Twitter, and I'll gladly answer them to you. Okay, and because you told me that you would prefer slides, you know what? Sorry, told me that you prefer code. We are going to switch to the IDE. I'm going to move to presentation mode. No, this is not what I wanted to do. Exit this. Presentation mode, please. Thank you. All right. The first thing I would like to show you is just a little. Why are you doing that to me? Okay, it's just a small feature of Java 17 that is very nice and that is going to improve a lot. It's not about record; it's about strings. Everybody uses strings, right? String of character, plain string of character. We've been doing that for years. Now, starting with Java 17, you'll be able to write string in that way. If I run this code, okay, there's no trick. There's nothing hidden. It's not a trick question. This is just a plain string of character that is working as expected. But starting with Java 17, you can write strings in that way. Okay? You see, I put three double quotes at the beginning of the string, then a carriage return, and then the text, and then another triple double quote. I could have put it here, it would have worked, but if you miss this one here, this carriage return there, it's not going to work. Here you have a compiler error. So the first carriage return is mandatory, okay? And if you run this code, well, the compiler is happy, and you always want your compiler to be happy, by the way. And you can see that the string of characters is still working, right? And if I do this kind of thing, you see I'm just adding carriage returns within the string of characters. You see that these carriage returns are going to be kept in the resulting string, okay? Well, this is new. Before Java 17, you couldn't do that. This special stuff, this special syntax, which is still a regular string, okay? It's a regular, plain instance of the string class. There's no particular interface it implements whatsoever. Is in fact called a text block. And a text block is a new stuff that you can use starting with Java 17, and that will help you hopefully write easier to read code, okay? If I add some content there, I'm going to move this here. You can see that the leading blank spaces I added in front of each line are kept by this stuff, meaning that the text block is keeping some of the blank characters that I added on it. And if I write this kind of stuff, you can also see that I do not have to escape any special character in a text block. Meaning that if you want to add some JSON content, some XML content, some SQL request in a text block, you will not have to escape any character, which is nice. No? It's not nice? I think it's nice, yeah. I think it's nice. In a text block, there are two kinds of blank characters. The blank characters that are here, you see that they are kept in the resulting message that I have there, right? But all the others, the ones that are there, have been removed by the compiler. In fact, there are two kinds of blank characters there. They are the characters that have been added by the IDE to indent my code, and the characters that I added myself and that are kept in a text block. And the limit, I don't know if you can see it, but here you have a vertical green line. You see there under my mouse? And this is the limit between what is called the incidental white spaces and the kept white spaces. Everything that is to the right of this vertical green line is kept, and the rest is not kept. The limit is just the position of this closing triple double quotes. If I move it 2 characters to the left, like this, you see that this green line has followed the movement, and this is, so the limit followed the movement. If I put this past the characters, of course, you see that this vertical line follows, in fact, the leftmost non-blank character that I have in my text block. You can also keep, let me put it this back there. You see that the IntelliJ, if I decide to mess up with the formatting, for instance, whoops, maybe I've been a little too long, and if I decide to reformat the code, this IDE is perfectly aware of the existence of these incidental white spaces and normal white spaces, and it will indent my code, respecting what I did. If you want to keep the blank spaces after the line, you can do so by adding this \s. So let me just do this. Okay. All right. Now, if I run this code, you probably won't see many things because, of course, these are white spaces, but you see that they are still there. What I can do is try to transform this string of character a little. Let me type this code, message.lines. This lines method is a new method on the string class. It will split the string of character on the carriage return and create a stream with all the lines of the string of character. So now I can map it, take each line, and do something like that. Plus line, and add this pipe character also after that. Sorry. Okay, and I'm going to put that in a list. I also have this new method on a stream API, which is a toList method, and this method is going to return a list of strings. Let me call it lines. Okay, it's almost a drop-in replacement for the collect.collectors toList call that you probably know on the stream API. It's easier to read, easier to write. It returns you an unmodifiable list, which is different than the collectors.toList, which returns you an array list. But in certain cases, it will be more efficient than it, because if the stream knows how many elements you have, how many elements you will put in this list, then it will create an array of the right size upfront, instead of create an array of a default size for a list. And then if this array becomes full, copy it into a bigger array once, twice, the third time, etc., along with the number of elements you need to put in it. So now what I can do is this kind of thing. Sorry, excuse me. I'm messing up with my keyboard. System.out println. Okay, so if I run this code, I should have, you see, all the vertical characters that are properly aligned because I just added the same amount of white spaces at the end of each line. Okay? So that is for the text block. I mean, it's not a big thing, it's not a revolution. It's super great to use if you have SQL requests or JSON to copy-paste in your Java code. You can now really directly copy that into your Java code. By the way, if you want to move to text block and you have already escaped characters because you have some legacy code, you can also escape these characters. Okay, so if I do this, these characters are going to be properly escaped. So it's fully compatible with your previous code. It will just support new kind of writing strings of characters. Okay? Do you like it? Well, I do like it. Any question about that? No? It's okay? Great. This was just a small appetizer. Let us talk about records now. No, you guys are for later. Okay, so what is a record? Well, you have a record here, just in front of you, and you can see that this code is compiling, right? So this strange syntax that you have is a proper Java 17 code. It's a record. What is a record? In a nutshell, a record is a class, okay? It's compiled as a class. It's a special kind of class because it already extends the record class. So if I try to extend something with a record, it will just not work. You see, if I type this kind of code, extend object, it will tell me, oh no, you cannot extend anything with a record. And it's also a final class. So you cannot create a class that would extend a record. This is not allowed. That being said, a record can implement any kind of interface. So there's no problem with that. And we are going to see an example, at least one example before the end of this talk. What if I run this code, you will see that I have this that is displayed on the console, right? Meaning that in this record class, I already have a toString method. If you're not happy with the format of this toString method, you can write your own, but if you don't, the compiler will give one to you, will create one for you, okay? And you have this weird declaration here. It looks like a constructor, but it's not a constructor because it's really along with the declaration of the record. It's range of int begin and int end. These are called the components of this record. And this component is really a new notion in the language that is bound to this record, to this notion of record. And it's super important to understand. This record is going to carry a state in the form of two final fields, int begin and int end. It will also have two accessors named after these components. So if I write this, int begin equals range.begin, you see that this code is compiling properly, meaning that this accessor method has been added by the compiler to this record class, all right? And they are, of course, immutable, okay? So once you have set the value of begin and end, you cannot change them. It's not allowed. Now, you may want to write your own accessors, and you can do that. It's perfectly fine. And by the way, along with the toString method, you also have an equals method and an hashcode method. So in fact, this class is just a data carrier. You can see that as a data carrier with final fields, private, accessors, a constructor, equals, toString, and hashcode. And that's it. And the declaration is just this one. So it's almost free to create a record. Of course, you can create a record in its own file. There's no problem with that. This is a local record, because you can also create your records in their own file, and they follow the thing that you need to do with regular classes. That is, if you want to put this record in its own file, it will have to be a range.java file, of course, just like any class. Okay, great. What can you do with records? Well, there is this constructor, and I'm going to add it, and I'm going to ask my IDE to do it for me, because I feel a little lazy today. Okay, yes, the canonical constructor, please. So this is the regular constructor of a record. You can write your own constructor. It's perfectly legal to do that. So if I just run this code, it will run exactly the same as the previous one. You can also add more constructor if you want. For instance, if I want a constructor that only takes the end as a parameter, you can see that here I have a compiler error. It tells me that the non-canonical record constructor must delegate to another constructor. There is a golden rule with records, is that you cannot create a record, you cannot create an instance of any record without calling the canonical constructor. And the canonical constructor is this one. Okay? The canonical constructor is the constructor that takes the components of this record, the components you declared. It's always there, you cannot remove it, and whatever you do, you need to call this canonical constructor if you want to create other constructors. So for instance, if you write this kind of code, this.begin equals 0 and this.end equals end, you will have a compiler error because this constructor does not call the canonical constructor. Okay? The right way to do it is quite simple, it's just this one. If I write this code, then the compiler is happy. And if the compiler is happy, yeah, good question? Yeah? If you have 10 parameters, you will have a constructor with 10 parameters. Yes, absolutely. Yeah. So if you want to create a builder, for instance, maybe this is what you have in mind, you will have to create that builder yourself. You can do that. You can do that. The compiler does not give you a ready-to-use builder. It doesn't do that.
What is the exact use case that you want to use?
We are going to talk about that. For the moment, I'm just showing you the stuff, and after that, we are going to play with him. Bear with me, we are going to do that. Okay? Why would you want to write your own canonical constructor? Well, there are two main reasons that you may want to do that. The first one is that you want to validate the argument you pass to the construction of your record. And the second one is you may want to do some kind of defensive copying. Okay? Suppose this range record takes a list as a parameter. You can pass an array list to the construction of this record, but you want to protect the internal list of this record from the outside. So in the constructor, you may want to create a copy of this list and store this copy within this record. This is called defensive copying. It's a very classical pattern. But if you want to do that, you need to write your own canonical constructor. Okay? Validation, let us suppose that if we only want ranges where begin is smaller than end, which kind of makes sense. Okay, so we can write this guy. If begin is greater than end, then I want to throw a new illegal argument exception. Begin should be lesser than end. Okay, and now I have my validation rule. Now, if I only need validation, that is, if this constructor ends with this code, then I can simplify its writing with the canonical form of the with the compact form of the canonical constructor. All right? This is exactly equivalent. The compiler will just add the other information for me. Here it works because I do not have any defensive copying. If I add defensive copying, I couldn't do that, of course. But in that case, you see, if I get rid of this constructor, you can see that creating this range record is super simple. A range has two components, begin and begin should not be greater than end. And that's it. You have all the information under your eyes at a glance, and all the rest has been generated for you by the compiler. Works well. Yeah, please? You can only have one canonical constructor because the canonical constructor takes all the components of the record. So it's unique. By definition, it's unique.
And is the record that specifies what is the canonical constructor? Is the record modified? Is the record keyword is what defines the canonical constructor?
Which keyword, sorry?
If I had defined another constructor,
yeah.
Here, it should have to call the canonical constructor, but by readability, how do I just see and figure out which is the canonical constructor?
Well, you need to compare the arguments with the definition of the components. This is what defines the canonical constructor. Okay? Golden rule, a record cannot be built without calling its canonical constructor. Okay? And this is super important, and we're going to see a consequence of that in a minute. And it's the only type of class in Java that has this rule. Any object in Java can be created by many constructors, and none of these constructors is mandatory. Neither the empty constructor, neither any other constructor. You cannot, you can create an object by calling any constructor, in fact. For a record, it's not the case. At the end of the day, you are going to call this canonical constructor. So if you put some validation rules in it, you're sure that they are going to be called. You cannot create corrupted records by some kind of backdoor whatsoever. Okay? Let me implement an interface just to give you a hint at what it's doing. We're going to implement iterable of integer. Okay? It doesn't compile, of course, because I need to implement the iterator method. So let me ask my IDE to create this method for me. And now I'm going to return an iterator, new iterator of integer. All right, I don't need this guy, so let me get rid of it. We are going to add a private state within this index, this iterator. As next is true as long as this dot index is lesser than end. Because I know that begin is lesser than end, well, I know that this index must go from begin to end. And next, we can just call this index plus plus. And now I have an iterable range, right? I can iterate over this range, so let me do that. I think I can type in, I have a nice template in this IDE to do that. So int index range, and I'm just going to print it on the console. And if I run this code, I should have the result. Okay? So implementing an interface is just as implementing an interface on any class. You've been doing that for 25 years, so it's worked exactly the same. There's one point I forgot to mention, is that if I try to add an instance field to a record, I will have a compiler error. Okay? You're not allowed to add any instance field to a record. You can add static fields if you want, static methods, no problem. Any kind of instance method, no problem, but no instance field. So it means that when you are looking at this part of a record, its declaration, basically, you have under your eyes the whole state this record can carry. Because it cannot extend any class, because it cannot be extended by any class, and because you cannot add instance fields, this is all the state a record can carry. Okay? And it has been designed to be like that, to just be as simple as possible. Now, I just told you that A record cannot be constructed without calling its canonical constructor. There is one case in Java where you can construct, where you can build instances of objects without calling any constructor. Anyone has any idea which is this use case? Sorry? Absolutely, deserialization. Deserialization does not call any constructor. Well, for records, it's not the case. Deserialization will call the canonical constructor of your record. And this has a consequence. I just prepared some code to show you. Okay? Here I have a range record, which is basically the same range record that the one we just wrote. I just commented the validation rule in a canonical constructor, written in its compact form. And here I have the equivalent as a class, right? This is the record. This is the equivalent class, basically. But it's a regular class. Look what is happening if I'm creating an instance of its class that is corrupted. I create it in that way. And I'm going to store this in this file, reread it, and in the first step, I'm going to just create this file. So what I'm doing is that I am creating on purpose a corrupted version of my range class, and I'm storing the serialized version of this object in a file. So let me run this code. Sorry, no, not you. Okay, so this file has been created. It carries a record that is not valid. Now I have a bug report from my security department telling me, oh, you forgot the validation rule. Okay, sorry, just fix the bug. Right? Now I have the feeling that I'm protected against any kind of creation of corrupted range. And I'm going to deserialize the object I just serialized a second ago. Right? It's in range class 10.0, so I'm going to run this code. And because the deserialization process, as you said it, doesn't call any constructor, my validation rule is bypassed by the deserialization. And now I have a class with a validation rule in it, and in my application, I have an object that is corrupted, that doesn't pass this validation rule, but that is there, and I need to deal with it. Now, why is this object here? Is it just by some kind of randomness, someone was not cautious enough? Or is it some kind of malicious stuff that someone sent me? So some kind of HTTP request whatsoever? And that is there to just put a mess in my application. I don't know, but the fact is I'm not protected against that. With records, it's not the case anymore. So we are going to run this exact same code, right, with a record. Instead of this range class, I'm going to create an instance of range record. Okay? And I'm going to put it in range class because the name of the file is really of no importance. Now, this record, the validation rule is commented. So I am creating a corrupted version of this record on purpose. Let me just run the same code. Okay. And now I'm going to do the same. I uncomment the validation rule. I'm fixing my bug. And I'm going to try to deserialize this corrupted file that I just created. Okay. Range class, range class. Let me run this code. Because the deserialization process does call the canonical constructor, my validation rule has been called, and I have an exception. This corrupted object will not be allowed in my application anymore. Okay? So this is really a security breach that is closed with records, and you should definitely, if you are using serialization and moving state around using serialization, you should definitely consider using that, taking a close look at that, and using that to fix your code. Because it's really a very annoying bug that has been there for years that is now fixed with records. Okay? By the way, if you don't feel like rewriting all your legacy classes with records, what you can do is also use this mechanism called read resolve, write replace, that will allow you to keep your legacy classes but serialize them as records and recreate them transparently for your code. Okay, so that's for the record and for, yeah, no pun intended, sorry. And for the use of the record serialization. Yes, question, please. Can you say that again, please? Okay, yes, it is. No, a record is a final class. You cannot extend it, and it cannot extend anything because it already extends the class name record internally. Okay, it's just like the enum class. You cannot extend an enum, and an enum cannot extend a class. So it's the same kind of construction. So let us take a look at what you can, how you can use records to make your code more readable, to improve the readability of your code. I have a file here. We're going to go through a little use case. I have a file which is a CSV file, and for each line of this file, I have a city, hopefully in the US. I think so. I think I have Atlanta, by the way, in this file. Yes, Atlanta is there. Okay, so Atlanta is the name of the city, Georgia is the name of the state, and after that I have the population, and after that the land area of this city. Okay, it's something I took from Wikipedia, so I didn't create this file. And I have some code here with a city record, and this city record is basically mapping the content of the file, each line of the file. I have the ID, the name, the state, the population, and the surface, all the land area. All right, this is technical code that is going to analyze each line. Yes, question?
Yeah, maybe you'll talk about it later. How does record play with Jackson?
Jackson serialization is not Java serialization. Is your question about serialization? Sorry.
Yes.
Okay.
How does it play with it? I mean,
It just worked fine. I mean, yeah, absolutely. You can add some code to map the content of a record to a JSON file without any problem. And if you're using Jackson as a serializer, it will just serialize the content of your record. Yeah, no problem with that. Okay, so this is the code that is just creating the city, an instance of city from this line. I can just run this code, the main method. Okay, I have a little more than 300 cities in this file. Fine. Now, what I would like to do is play a little and just use the Stream API to extract some information from this file. So for instance, I would like to have the list of all the states referenced in this file. I can do that from the cities list that I just built, called the Stream method, and then map each city to its state. I'm going to use a method reference for that. I guess you're all familiar with this syntax. I'm going to call distinct and put the result in a list. And this is going to be a list of string, of course, a list, thank you, of string, and I'm going to call it state. Okay, I'm not going to display it because there are a little too many of them. States the size, maybe enough. This is the number of states. And if I run this code, you can see that I have 46 states, which sounds reasonable. Maybe I don't have all of them. Okay, so if I want to compute the population by state, that is, have a hash map, the keys are the states, and the values are the number of people living in that state. That is, I need to regroup the cities by their state, and then sum the population of these cities to construct this hash map, which is basically an histogram. It's a very classical stream code. That is population by state. How can I do that? Regrouping cities by state is a job for our good friend, the collectors.groupingBy collector. So I'm just going to call cities, stream this list, and then call collect. Collectors. No, it's not collections. Okay. Grouping by, please. Yes, this one. I need to pass a classifier to this grouping by, which is just the state. So it's city state. And then I need to post-process all the cities bound to a given state. And what I want to do is just sum the population. And it turns out that I have a collectors to do that. Collectors that's summing int, okay, that takes the mapping function to map the city to its population. So it's just city population. And that's it, okay? I can just print out the size of this map. and the size should be the same as the number of states that I have. So if I run this code, because this is a little too big to be displayed on the console, I still have 46 key value pairs in this map, which is expected. And now the last step is quite natural to do that. I would like to know probably the most populated state, so I have the max of this histogram by its values, that is by its integers. Okay, so I'm going to do that real quick. Population by state, entry set, dot stream, no, not that side, that stream, takes the max. Now I have factory methods on the map entry interface, map.entry, and I have in fact four comparator created for 4 factory methods to create comparators to compare map entries, and here I need to compare the map entries by value. So this is the factory method I want to call. It returns an optional. I need to open this optional, but hopefully this optional is not going to crash because the map is not empty, so the optional will not be empty neither. And what I get there is a map.entry, and this is the most populated state. Populated state. Okay, let me format this, print the result, run this code, and the most populated state is California with something like 19 million people living in it. Okay? So this is very classical stream code. This is basically Java 8 code, all right? There are maybe this or else throw method is not a Java 8 method. Could have called the get method, but it's basically Java 8 code, Java 8 concept. Now, suppose I call this entry, okay, and this map. All right? And now I'm asking you, what is this code doing? Do you have the feeling that reading this code explains you what it's doing? That it's dealing with a list of cities, dealing with a list of states, summing up population, and this kind of thing. The readability is, okay, the basic idea when you want to do clean code is to choose meaningful variable names, right? This is what I tried to do. Maybe it was not that great, but this is at least what I tried to do. But it's really the only thing that is giving me hints about what is this code doing really. This is purely technical code, and the business meaning of this code is completely lost. Why is it completely lost? Because this string is really a state, and this integer here is really a population, but I don't know it. It's not written in my code anywhere, all right? Choosing meaningful variable names is one thing, but choosing meaningful type names is another thing. Now, how can you modify the name of a string? You cannot do that. Well, fortunately now we have records, and records is going to change your lives. Okay, suppose I create a state record and say, yeah, this record has a name. And instead of saying that this city is built on a string, it's built on a state. Okay, that's not compiling anymore, so I'm going to say that this is new state. All right. Now this guy is not happy because this is really a state. And the same there. The key of my map are states, and this is also a state. And you see now I'm dealing with a list of states. I'm not dealing with a list of strings anymore. This code is working just the same, right? What was the price to pay to create this record? Well, next to nothing. I just had to write a very simple line of code. Can I do the same for the population? Well, I think I can. I'm going to create a population record, and I'm going to wrap, let me call it amount, all right, and let me say that now this population is new population of this integer, okay, and that this city is in fact built on a population element. I have several things that are not compiling anymore. This collector is not working anymore because I'm trying to sum population objects, and of course you can sum integers, you cannot sum population objects. So I'm going to fix that. I have something else that is not compiling here. Oh yes, here. What you doing? Oh, you're missing this? No, you're not missing this. You have one more here. Great. Okay. How could I fix this collector here? I'm going to say that CTE, now I need to map it to population, okay, and amount to get the integer. If I do it in that way, it's working, but what I get here now is a map of state and integer, and what I would like to have here is not an integer, but a population element. So to do that, I can wrap the result in another integer, in another, using another collector, called, which is the collector. I don't know if you know these collectors. Collectors finishing and then. Sorry. It's not this one. Collecting and then. Excuse me. Collecting and then. This is the first collector. And after that, I'm going to put this in a population object. Okay. Is not happy because this is now a population object. Okay. This collecting and then stuff, technically it's not used, but when you are joining a string of characters, for instance, what you are joining is not string of characters, you're just appending them in a string builder, and at the end of the day, you need to call the toString method of the string builder. This is the exact same kind of pattern that we're using there. Yeah, question?
So similarly, if I need to use string builders, I have a library and all, so I need to first get the string out of it.
Yeah, yeah, absolutely. Yeah, you could do that. What you could do also is you just use the collector that's reducing, okay, to reduce two population elements together. But if you do that, it will create another population for each addition. Here it just add all the integers and create a single population object at the end of the computation. So it's probably more efficient to do that. To do this in that way, sorry. Okay, so now my map entry is a map entry of integer, and this guy is complaining because this value should be comparable, okay? And this population record is not comparable. But we saw that you can implement any interface with the population. So making this population object comparable, it's a comparable of population, of course, should be super easy, and it is super easy, okay? All I need to do is add this method, compare to, other, and now what I need to do is compare the two amount wrapped by this population object. They are integers, so integers that compare this dot amount and other dot amount. Okay, and now my code is happy, and if my compiler is happy, I'm also happy because I like my compiler to be happy. Of course, and if I run my code, it will run the same. Just run the same. Okay, I can go one step further because this collector is really not the nicest piece of code I've ever written. We are talking about readability of your code, and there is this guy in our way, which is not great. But what you can do really is put it in a variable. Let me call it downstream. Okay, this is not an object. This is more a question mark. Let me just compile that, and I can hide that behind a method. Let me call it. Yes, get downstream, that's fine. Where are you? You're here. I'm going to make you static. And to move you to the population record. Yeah, please. Great. So now you should be, where are you? You should be in the population record. This is downstream. I'm going to inline it again. Okay. Oh no, I don't want this cast. Sorry? Oh. So it's again downstream. How can I rewrite it? Something like summing? Is summing okay? Is it better like that? Now my collector is hidden in a. I could make it public. Don't make it. Okay. It's hidden behind in a factory method. Okay, so it's not in my way anymore. And now I can play with this kind of trick that is hide your technical code in meaningful method just to make my code more readable. And now I'm happy because what I have is a map of state and population, And I think it makes my code much easier to read and much easier to understand. Okay? What was the price to pay? Well, the price to pay was create this record. Okay? Next to 0, we all agree on that. This record is a little more complex, but because it has to be comparable. All right, creating a comparable object is not the hardest thing I've ever programmed in my life. And there was just this collector to create, which was a little hairy, but which is now hidden in a static method, so it's not in my way when I'm reading my code. Okay? So you see that record can be very efficiently used just for that, just to make your code more readable. It's a type that you can create. And what did we do, in fact? What is from a pure object-oriented programming point of view, what is the status of this record? This record is an extension of the string class. But because the string class is final, you cannot extend it. And if you cannot extend a class and you need to extend it, what are you doing? You are just composing it. It's just a composition of a string class. And you're perfectly in line with the gang of 4 program, which is favor composition over inheritance. So even if this string class was something that you could extend, it's always better to do that rather than to extend it. And we did the same for the population. This population record is just a wrapper on an int, just to add behavior to this int and to give it meaningful business meaning. Okay? So that's it. Yeah, question? Yeah. Mm-hmm. Yeah. Mm-hmm. I would say that it's probably good enough. You already have an equals and a hash code method in these records. So yeah, if you want to have your own equals method, you can write it. The compiler give one to you by default with the default behavior, but if you're not happy with this behavior, you can just write your own. There's no problem with that. Is it your question?
My question is, if I want to compare 2 states,
yeah?
it's going to compare the names.
Yeah?
What is not going to compare the names?
Yes, this is what it's going to do. Yeah, absolutely. Absolutely. Now, if you want to compare two, suppose that with the state you also have a list of cities, and you only want to compare the name, then you need to write your own equals method, and you can do that. It's perfectly legal to do that.
It's only specifically in the cases like you would have ignored cases where you have to basically write an implementation.
Yeah, absolutely. Absolutely. Which makes sense, by the way. I mean, okay? Yeah, please. Sorry. Oh, sorry, you need to speak louder.
How easy or difficult is it to replace an existing final Java class?
Yeah.
Java bean convention.
Yeah. So if you have a regular Java beans is a mutable object, and a record is an immutable object. So as long as you're comfortable with not mutating your Java bean, you can do it. But it may not be possible. Plus, a Java bean needs to have a default constructor because many frameworks are creating Java bean using reflection, and there is no empty constructor in a record that cannot call the canonical constructor.
If there is a immutable Java bean,
yeah.
my question is more about the convention of this method.
Mm-hmm.
Java bean has this getter and getter.
Yeah.
This one does not. So if the bean is changed to a record, then the entire code needs to be refactored.
Yeah, but you can create this method yourself, right? You can add any instance method on a record. So if you absolutely need a get begin and get end method, you can just add them yourself, and it will work. There's no problem with that. But once again, a Java bean is most of the time created using reflection, and it will not work well with records at this point. So you need to check if it's working or not in the case of your application. Yeah, question? Okay. When you're comparing records, you mean with equal equals? No, it's a regular object. If you call equal equals, it will just compare references. If you want to compare them properly, you need to call the equals method. Yeah. Well, you can use the default equals method that is given to you by the compiler, but you can also write your own equals method if this is what you need. Okay? I'm not sure how much time I have left. Is it 5 minutes or so? Okay. I have very little time to talk to you about pattern matching. Let me try to be really quick. All right. I have a shape interface. I'm going to be as quick as possible. Pattern matching is 5 minutes. That's going to be fast. I got this shape interface, and I have two classes, square and rectangle, that are implementing this shape interface. Okay? Suppose I want to add a business method, because I work in a startup, and the business of this startup is to compute the surface of geometrical figures. And I need to create a surface method. There are many startups that are doing many, many funny things like that, right? Compute the surface of this stuff, okay? What is the first reflex you may have if you want to do that? Okay, I'm going to add int area there. Plain and simple. Why is it a good idea to do that? It's a good idea because the compiler, who is my friend, really, okay, will tell me, oh, you forgot to implement this method in this class, and by the way, you also forget to implement it there. Every time I do that, the compiler will help me, telling me, hey, you need to provide an implementation here, here, and there, right? And this is why I like this solution. Now, what is the cost of this solution? Well, tomorrow I will have a perimeter surface to add, and the day after another method, and the day after another method. If every time I need to add some kind of behavior to my hierarchy, I add a method on the interface, what is going to happen before long, before 3-5 years? I will have 50 methods there, a bunch of fields in my classes, and every time someone tells me, oh, but we don't need the area method anymore, what I'm going to do? Well, I'm going to keep it, because there is no way I can track who is calling this method. So this kind of idea of hiding content, hiding behavior to interfaces is a nice idea, but it doesn't lead to very clean code. It's not a very clean idea. I'm not going to in more detail in that, because I'm lacking time, but there are many, many good reasons why you don't want to do that. Now, there's another way to do it. If you don't decide not to do it, I'm going to create an area method there and say this area method is taking a shape as a parameter. Yes, this shape that I want, not the AWT shape. And I'm going to say return 0 just to make the compiler happy. Okay, now I am in my business module. I am the one who is needing the area method, so I'm putting it in the business part of my application instead of putting it in my object model, right? But then the implementation of this guy is what? I need to check if the shape is a square or a rectangle. So I would end up writing this kind of code. Is shape instance of rectangle. Okay, return shape dot 8 times. I love this idea. Did I already say it? Shape dot width. Okay, and if it's not the case, and if it's a square, then I'll do almost the same. Please. Return shape dot edge to the square. Okay? What do you think about this code? It's ugly, right? We all agree on that. Well, starting with the Java whatever version, but you have it in Java 14, you can improve it a little by saying that this rectangle is a rectangle and this square is a square. Can I do something like that? No, I can't. And here I can directly use this rectangle, and here I can directly use this square. Now, you may be thinking that this is just a syntactic sugar, and it's from some point of view, it is a syntactic trigger. But it's in fact much more than that. This is really a pattern. And I'm checking if this variable matches this pattern. This pattern has a name, which is rectangle. It's a type pattern. And it has a binding variable, rectangle, which is going to be created if the variable that I have here matches the pattern. That is, if shape is a rectangle, then this variable is created. Okay? And I can use this variable wherever it makes sense. For instance, here I could say, okay, I want this rectangle to have a width that is greater than 0. Okay? It makes sense to use this variable there. It makes sense to use this variable in the right branch of the if statement, so I can do that. Right? So it makes this code a little better. But what is happening if I decide to add an implementation to this shape hierarchy? Well, I will hope that I am a master of the grep Unix function, because I will need to find this if, else if everywhere in my code to add a third case, if shape instance of blah, blah, blah. And I will probably forget about some of them, and it will be a mess, and I'll have bug in my code. If I leave the code there, like this one, it means that all the circles of my application will have an area of 0, okay, which is probably not the case. Right. But this if statement has the structure of a switch, right? In Java 17, switch is in fact well, you can use switch as an expression, and you can do this directly. Switch on shape. Okay, and in case this shape is a rectangle, then I want to return this. And in case this shape is a square, I can return this directly. Okay. I need a semicolon here. I can get rid of this code. And I have a compiler error because the compiler is able to check that if the switch is covering all the values, and it's not, so I need a default statement telling that I want to return 0. By the way, and this is so awesome, I can also handle null cases. Wow! 25 years. Of waiting, we got it now. Okay, and you can see, so this code is probably a little more readable. I improved the readability, but I lost this capacity I used to have, that if I forgot to implement this area method in one of my case, the compiler would tell me. And this is where SIL types are coming into the game, because I can make this interface a sealed interface. A sealed interface has to declare all the classes that are allowed to implement it. Squared and rectangle. Okay? If I try to say that circle implements shape and circle is not in the permitted list, then I will have a compiler error. If I try to sneak through a backdoor by creating a class at runtime using some kind of agent, reflection, class loader, bytecode manipulation, whatsoever, blah, blah, blah. To create such an implementation, the JVM will catch me. It will not work. And now in this switch, I have a warning here telling me that, oh, but this default branch is not necessary. Because shape is a SIL type, the compiler is able to tell that I have all the cases there. Okay, so I can get rid of this, which is super, and which is what is even greater is that I'm going to add circle as a permitted class there, tell that circle implements shape, and what I have now here is a compiler error telling me that this switch does not cover all the possible values. So with this combination of SIL types, records could be classes there. I chose to make record because it's simpler, but it could have been classes. SIL types and pattern matching on switch, I have the best of both worlds, right? I can put all my business stuff in my business module. I completely leave aside my interface. It stays clean, no more dead code in it after 3 or 5 years. all right? But if I forget a case, then the compiler will tell me, just as it's used to tell me that one of my class that was implementing this interface was missing an implementation of my method. Okay, question?
So we implemented circle, but if I don't define it in the permitted types,
Yeah.
then the compiler will show error saying that somebody is implementing a circle, but it's not permitted.
Absolutely. We can check that really quick. Hang on, I would just like to add circle there so that the compiler is not yelling at me anymore. Okay, circle.radius times circle.radius. And you know, because we are all friends here, we're going to say that pi equals 2, which will make things a little simpler. Okay, and I'm going back to circle. Now, if I remove circle from here, okay, it will tell me that, oh, shape seal class permit clause must contain all subclasses. All right, and I also have an error on the circle side here telling me, hey, circle is not allowed in the seal hierarchy. This is at compile time, and at runtime, if you try to do that, you will also be caught at runtime. There are some limitations on the seal classes, etc., but I'm not going to go. We are already a little over time, so I don't want to go any further. So that's what I wanted to tell you today. Okay? I told you not many slides. I think we were 3 slides, something like that. Okay. Any more questions? Anyone? Okay, please.
Is there a case to use entity classes instead of for records? So can you use records for entity classes?
You mean in JPA?
Yes.
No, you can't, because an entity class is a mutable class. It doesn't mean that you cannot use record in the context of a persistent unit. Okay, maybe you can probably use them in your as data transport objects, for instance. But as an entity class is a mutable class. It's created using reflection as an empty class, and all the fields are initialized one by one using reflection. And this with records, you cannot do that.
You can use it for the data and the value processing.
Yes, absolutely. And the fact that it has this very nice serialization property will help you in this matter. Yes, please.
So all these examples for pattern matching are type patterns, right?
Yes, absolutely.
What is the difference between the deconstruction pattern, which I heard about it, I don't know what exactly does it mean or what it applies to, and the type?
I'm going to answer your question. Is the next speaker here, please? No, okay, so I'm answering your question. I'm over time, so I don't want to be rude with the next speaker. I'm going to show you because I have the slides. Deconstruction is the next step of pattern matching. By the way, you know what? I'm going to show that to you, which is the last slide. So pattern matching for instance of, we have it. It's a final feature of 16, so you have it in 17 as a final non-permanent feature. What I showed you is for the pattern matching for switch is still a preview feature. You cannot use it in production in Java 17. It will be for the next LTS version, okay? And in 19, there will be another preview feature of pattern matching for switch. So it may be a final feature for 20, but not before 20. Record pattern matching, which is your question, will hopefully be a preview feature in 19, next September. We will have a release candidate before that, so you'll be able to play with that before September, but the preview feature is probably for September. And there are other forms of pattern matching. I'm not going into details about that. Record pattern matching is this guy. Let me show you, but this is a record pattern matching. Okay, if you're doing this kind of thing, where is it? Sorry, it's here. If you're doing this kind of thing, I have a record user with string name of int age. Okay, and I'm just checking if O is an instance of user, and after that I'm going to extract name and age using the accessor. Very basic code, I showed you that just a minute ago. With record pattern matching, you'll be able to match O with this syntax. Okay, so now it's a record, but you have the components of the record there, and because you know that they are the components, the name and the age here are binding variables. If I go back to the previous slide, this is the binding variable of this pattern, but I'm not limited to just one binding variable. I can have more than one. And in the case of record pattern matching, here I have two, because I have two components for my record. So this is a way, it's also called deconstruction. This is exactly what you said. It's also called deconstruction. So basically we are deconstructing a record, and because the record is built on components, we have the exact right concept to do that. But there's more to come. We'll be able to deconstruct using factory methods, using regular constructors of regular classes, etc. This is all in the way. Does that answer your question? Thank you. So, sorry, can you say that again, please?
I mean, the difference between the previous one and this one.
Yeah?
The second one is more verbose.
You mean this one?
Yeah, right. With the name and age, the name and age are the one which is the definition.
You're saying that this one is more verbose than this one? This is what you said? Well, I don't think so, sorry. Here you have to explicitly call the two accessor methods. Here you don't call anything. The compiler is doing that for you. Maybe you don't have to agree with me. Huh? Yeah. And if you're not interested in the age, you can just write this guy, and you're just suppressing this binding variable. And if you want to just write var here, you can do that also because it supports type inference. I'm going back to my original slide, sorry. Because this is a slide. Okay? Yeah. Okay, is there another one last question? Okay, so the last question for this young lady in front of me.
Record pattern matching is like this.
Yeah.
For the array pattern matching, this is also coming in Java 19 because the JEP was changed.
Absolutely, the JEP was changed. Originally, the JEP was talking about record pattern matching and array pattern matching in the same JEP. They have been separated, and it seems like the first thing we're going to have is record pattern matching. Record pattern matching. Array pattern matching, which is this guy. Okay, basically this. Okay, would probably be done, but later on. Later on. It's fine. If you have more questions, please come by. We'll just hang around in the booth area. I'll be more than happy to answer your questions. Thank you for coming. Have a great evening.